is still one of the correction videos for step 10 of the 9x9 Kenken with no operation signs from mathmojo.com/Kenken. This is step 10B. In the last step, step 10A, we decided to try this 4 here, go down this rabbit hole, which would make this a 9 here. In this step, we realize this 4 will make this 4 impossible. So this will be a 2. And that means this one must be a 4. That's simple enough so far. Now when we check this far right column, you have to get the 2's in the 15 cell out of the way because we've used this 2 here. So all the other 2's, that would be these 2, have to go. That leaves the 6 and the 1 mandatory there. If this is a 6, this must be a 1. If this is a 1, this must be a 6. So the 6 and 1 will be used no matter what. That means all other 6's, which there aren't any, and 1's, which there was, but it's already crossed out, must go. That leaves us with only an 8 in the upper 5 cage and a 3 in that cage's other cell. See how this was, because this 2 has to go here also, because of this 2. So this makes this an 8, and it makes this a 3. Well, that gives us something. In the 24 cage on the far left, the only possibilities here, it would have been, think about it, 24, the only possibilities are 3 and 8 and 4 times 6. 3 times 8 or 4 times 6. Well, we can't use the 3 and 8 because we've used them over here in the 5 cell. Hasta luego. And we can't use this 4 because of this 4 here that we've already proven in step 19 and 20, which we jumped ahead to and we talked about in lesson 10A. And if you don't know what I'm talking about, you got to go back to that lesson. So this is a 6. Well, if this is a 6, the only way you can combine it to get 24 is to multiply it by 4. So, you know, a few things are happening. But as we know from having jumped ahead, yeah, right. I'm sorry, I'm repeating myself. So we can get rid of this 4 and this 6 for sure, right? And we can also, let's see, is there anything else we can get of any other 6's here? Yep, we can get rid of this 6. Any other 4's? Nothing here. So that has us using the 1, 3, 4, 6, and 8 in this row. 1, 3, 4 here, 6 here, and 8 here in that row. That leaves only the digits 2, 5, 7, and 9 for the rest of the row, for the empty cells in that row. 7 doesn't factor into the 36 cage. 7 isn't a factor of 36. And we can't use 7 here in this 1 cell because of this 7 down here in this column. So if this 4 is correct, which we're guessing, if our rabbit hole is correct, that means the only place left to put a 7 would be here. And while we're at it, let's trash some. That's going to be meaningful in a minute. So you can't go there. The 2, 5, and 9 are left. Since 5 doesn't factor at all into 36, it's going to have to go here. And that leaves us with the 2, 9 combination here. And that would be possible, conceivably, but the 2 would have to go here because the only way to make 36 is 2 times 2 times 9. And as you know, we can't have 2 in the same row or in the same column. This is the only combination that could possibly work like this. Later we'll see how meaningful this 7 was and a few other things. That's the end of step 10B, and we'll hit 10C in the next video.